The Chernobyl disaster is one of the most catastrophic nuclear accidents in history. It occurred on April 26, 1986, at Reactor 4 of the Chernobyl nuclear power plant near Pripyat, Ukraine, during a late-night safety test. The test was intended to simulate a power outage and determine whether the plant's turbines could generate enough electricity to keep coolant pumps running until emergency generators activated. However, a combination of operator error and serious design flaws turned the test into a disaster. Operators lowered the reactor's power to an unstable level, violating safety procedures. They disabled key safety systems and withdrew too many control rods, leaving the reactor in a highly reactive state. The RBMK reactor design made matters worse. Instead of dampening reactivity as water turned to steam, it became more reactive. At 1:23 a.m., the emergency shutdown button was pressed. But due to a design flaw, the graphite-tipped control rods caused a sudden spike in reactivity. This triggered two explosions that destroyed the reactor core and released massive amounts of radioactive material into the atmosphere. 2 workers died immediately, and 28 first responders died within weeks from acute radiation sickness. In total, about 50 direct deaths were recorded. However, the long-term health effects were far more severe. Thousands of people, especially children, developed thyroid cancer and other radiation-related illnesses. Over 100,000 people were evacuated from surrounding areas, and a 30-kilometer exclusion zone remains uninhabited to this day. The disaster was not only a result of technical failure, but also of a flawed safety culture. Warnings were ignored, safety procedures were lacking, and prior accidents had been hidden. In the end, Chernobyl was a preventable disaster made worse by systemic human mistakes at every level. The Challenger space shuttle disaster occurred on January 28, 1986, when NASA's shuttle broke apart just 73 seconds after liftoff, killing all 7 crew members on board. The launch took place at the Kennedy Space Center in Florida and was widely watched, especially because it included Christa McAuliffe, a schoolteacher who would have been the first civilian in space. The cause of the accident was the failure of an O-ring seal on the right solid rocket booster. These rubber seals were designed to prevent hot gases from escaping the booster joints. However, on the morning of the launch, temperatures were unusually low, around freezing, which reduced the elasticity of the O-rings. Engineers from the contractor, Morton Thiokol, had warned that the cold weather could make the seals fail. Despite these concerns, NASA approved the launch. Just over a minute after takeoff, hot gas escaped from the faulty seal and burned through the external fuel tank, causing it to rupture. This led to a structural breakup of the shuttle. The vehicle disintegrated in midair, and the crew cabin fell into the ocean. The explosion was broadcast live on television and shocked viewers around the world. The exact time of death is unclear, but evidence suggests that the crew may have survived the initial breakup and lost consciousness during the descent. The Challenger disaster was the result of a combination of technical failure and a flawed decision-making process, where launch schedule pressure overruled engineering concerns. It led to major reforms in NASA's safety culture. The Bhopal gas tragedy is considered the world's worst industrial disaster. It occurred on the night of December 2nd to 3rd, 1984, at the Union Carbide India Limited pesticide plant in Bhopal, Madhya Pradesh, India. The disaster happened when water entered a storage tank containing methyl isocyanate, a highly toxic and reactive chemical used in pesticide production. The resulting reaction produced a large volume of heat and toxic gas. As pressure built up, safety systems failed or were not active, and around 40 tons of MIC gas were released into the air. The gas spread quickly over the densely populated areas surrounding the plant. People woke up coughing, choking, and experiencing severe eye and respiratory irritation. Many collapsed while trying to flee. Estimates vary, but it's believed that over 3,000 people died within the first few days. Long-term death estimates range from 15,000 to 25,000. Over 500,000 people were exposed, with many suffering permanent disabilities, respiratory illnesses, eye problems, and reproductive complications. Investigations revealed multiple safety lapses. Critical equipment like gas scrubbers and flare towers were non-functional or turned off to cut costs. Storage tanks were overfilled, maintenance was poor, and staff were undertrained. Despite clear warnings and past leaks, no serious safety upgrades were made. The Bhopal disaster was caused by a combination of poor maintenance, ignored warnings, cost-cutting, and weak regulation. It exposed serious flaws in corporate responsibility and industrial safety standards. The site remains contaminated decades later, and many survivors still await full medical and environmental compensation. The Deepwater Horizon oil spill, also known as the BP oil spill, was one of the largest environmental disasters in history. It began on April 20, 2010, in the Gulf of Mexico, when a drilling rig operated by BP suffered a blowout during the final stages of drilling an exploratory well. The immediate cause was the failure of the blowout preventer, a critical safety device meant to seal the well in emergencies. A surge of natural gas traveled up the well and ignited on the rig, causing a massive explosion. 11 workers died, and the rig sank 2 days later. With the wellhead broken on the seafloor, oil began leaking into the ocean, and it didn't stop for 87 days. An estimated 4.9 million barrels of crude oil spilled into the Gulf before the well was capped. The disaster wasn't just an equipment failure. Investigations found that BP and its contractors had ignored warning signs, skipped crucial safety checks, and made cost-cutting decisions that increased risk. A cement seal in the well had failed a pressure test, but operations continued anyway. The spill devastated marine ecosystems, killed thousands of marine animals, and caused long-term damage to fishing and tourism industries across the Gulf Coast. Cleanup efforts involved thousands of personnel and took years. The Deepwater Horizon spill highlighted the consequences of prioritizing speed and savings over safety in high-risk industries. It led to billions in fines and stricter offshore drilling regulations. But the environmental cost is still being felt today. The Fukushima Daiichi nuclear disaster occurred on March 11, 2011, following a massive 9.0 magnitude earthquake off the northeastern coast of Japan. It wasn't the earthquake alone that caused the crisis, it was the tsunami that followed. A 15-meter-high wave overwhelmed the plant's coastal defenses and flooded key infrastructure. Backup diesel generators, located in low-lying areas, were knocked out. Without power, the cooling systems for multiple reactors failed. As temperatures rose, fuel rods overheated and began to melt down. Over the next several days, hydrogen gas built up inside the reactors, causing a series of explosions that damaged the reactor buildings. Radiation began leaking into the environment, prompting a mass evacuation of over 150,000 people from surrounding areas. While the earthquake and tsunami were natural events, the disaster itself wasn't entirely unavoidable. Critical vulnerabilities had been known. For years, experts had warned that the plant's seawall was too low and that emergency systems were poorly positioned. TEPCO, the plant's operator, had postponed improvements and failed to act on multiple risk assessments. In the end, 3 nuclear reactors suffered meltdowns. Radioactive material contaminated land, air, and ocean water. The cleanup is ongoing and expected to take decades. Fukushima was a stark reminder that natural disasters can expose and magnify human negligence. It also raised global concerns about nuclear safety, prompting some countries to rethink or phase out nuclear energy entirely. In 1999, NASA lost a $327 million spacecraft because 2 teams used different measurement systems. The Mars Climate Orbiter was launched to study the Martian atmosphere and serve as a communications relay for a lander. After a nearly 10-month journey through space, everything seemed on track, until it came time for the orbiter to enter Mars's orbit. That's when the mission failed. The spacecraft descended too low into the Martian atmosphere, where it likely disintegrated or skipped off into space. The cause? A simple yet critical error. One engineering team had used imperial units, pounds of force, while another used metric, newtons. The mismatch went undetected. There were no hardware failures, no last-minute emergencies, just a miscommunication between software systems. But that small oversight led to the total loss of the mission. Post-incident reviews revealed a lack of cross-checking and systems integration. Despite multiple points where the error could have been caught, no one noticed. It was a breakdown in process and coordination, not technology. The Mars Climate Orbiter crash became a textbook example of how even highly advanced space programs can fail due to basic human error. The sinking of the RMS Titanic on April 15, 1912, remains one of the most infamous maritime disasters in history. Marketed as unsinkable, the Titanic struck an iceberg just 4 days into its maiden voyage from Southampton to New York City. The ship was equipped with advanced technology for the time, but a number of decisions and assumptions contributed to the tragedy. Warnings about icebergs had been received earlier in the day, but the ship maintained high speed. The lookout team had no binoculars, and visibility was poor that night. By the time the iceberg was spotted, it was too late to avoid impact. The iceberg scraped along the ship's starboard side, rupturing multiple watertight compartments. Titanic was designed to stay afloat with 4 compartments flooded, but 6 were compromised. The situation worsened due to a lack of lifeboats. There were only enough for about half the people on board, and many boats launched partially empty due to confusion and poor training. Out of over 2,200 passengers and crew, more than 1,500 died, most from hypothermia in the freezing Atlantic. Investigations that followed pointed to overconfidence in design, inadequate safety planning, and poor emergency response. The disaster prompted major changes in maritime safety laws, including lifeboat requirements and continuous radio monitoring. The 3 Mile Island nuclear accident occurred on March 28, 1979, near Harrisburg, Pennsylvania. It remains the most serious nuclear incident in U.S. history, not because of massive loss of life, but because of how close it came to disaster. The problem began with a minor mechanical failure. A pressure relief valve stuck open, allowing coolant to escape from Reactor 2. Alarms went off, but operators misinterpreted the situation. Believing the reactor had too much water, they reduced coolant flow, when in fact, it had too little. This led to a partial meltdown of the reactor core. Though the containment structure prevented a full release of radiation, small amounts still escaped, raising public concern and prompting the evacuation of thousands. No immediate deaths or injuries occurred, but the event sparked national panic. The crisis highlighted deeper issues: poor operator training, confusing control panels, and a lack of clear communication during the emergency. At the time, the nuclear industry had grown rapidly in the U.S., and confidence was high, but 3 Mile Island exposed just how fragile that system could be when human judgment failed under pressure. The accident didn't destroy a city or take lives like Chernobyl or Fukushima, but it shook public trust in nuclear energy. Several planned plants were canceled, regulations were tightened, and the U.S. nuclear industry never fully recovered. On January 15, 1919, a massive storage tank filled with 2.3 million gallons of molasses burst in Boston's North End. What followed was one of the most bizarre and deadly industrial accidents in American history. The tank, owned by the United States Industrial Alcohol Company, was poorly constructed. It had been leaking for months, and workers even painted it brown to hide the stains. No formal inspections were done, and safety concerns were ignored. Around 12:30 p.m., the tank ruptured without warning. A 25-foot-high wave of molasses rushed through the streets at over 30 miles per hour, sweeping away everything in its path. Buildings were crushed, horses drowned, and freight cars were tossed off their tracks. 21 people died, and over 150 were injured. Rescue efforts were difficult. The thick syrup made it nearly impossible to move. It took weeks to clean the streets, and traces of molasses lingered for months. Investigations later revealed that the tank had been built with steel too thin for its size, and basic safety tests had been skipped. The company had rushed to build it during World War I to meet high demand, prioritizing speed over structural integrity. The disaster led to major changes in building codes and industrial regulations in the U.S. It also became a case study in corporate negligence. On August 10, 1628, the Swedish warship Vasa set sail on its maiden voyage and sank less than a mile from shore. It had been in the water for barely 20 minutes. Vasa was built to be a symbol of Swedish naval power, heavily armed, elaborately decorated, and commissioned by King Gustavus Adolphus himself. But from the beginning, the project suffered from poor design and political pressure. The king demanded more cannons than originally planned, which made the ship top-heavy. At the same time, no one wanted to challenge royal authority, so concerns about stability were ignored. In fact, stability tests were done, and when the ship swayed dangerously, just from a few men running side to side on deck, officials simply stopped the test and said nothing. On launch day, with hundreds watching, Vasa caught a breeze, tilted, and water poured through the open gun ports. The ship capsized and sank in full view of the public. About 30 people died. The disaster was a result of poor communication between designers, builders, and leadership, and the fear of speaking up. No one was ever formally punished. Vasa remained underwater for over 300 years before it was salvaged and placed in a museum. Today, it's an incredibly well-preserved reminder of 17th-century ambition and overconfidence. The deadliest aviation accident in history didn't happen in the air. It happened on the runway. On March 27, 1977, two Boeing 747s, operated by KLM and Pan Am, collided on the runway at Los Rodeos Airport in Tenerife, Canary Islands. The crash killed 583 people and left only a handful of survivors. That day, multiple flights had been diverted to the small airport due to a terrorist bombing at a nearby airport. The ramp was overcrowded, visibility was poor due to thick fog, and radio communication was strained. As both planes prepared for takeoff, confusion built. The KLM aircraft began accelerating down the runway, believing it had been cleared for takeoff. At the same time, the Pan Am flight was taxiing in the opposite direction on the same runway. Neither crew could see the other due to fog, and air traffic control had not clearly confirmed the runway was clear. By the time the Pan Am crew spotted the KLM jet bearing down on them, it was too late. The aircraft collided at high speed. The KLM flight became airborne briefly before crashing and bursting into flames. Most passengers aboard both planes were killed. Investigations pointed to a breakdown in communication, poor phraseology, and human error under pressure. The KLM captain, one of the airline's most experienced pilots, had misinterpreted the clearance. The tragedy led to major reforms in aviation communication protocols, including standardized phrase usage and cockpit resource management. Tenerife proved that even experienced professionals can make fatal errors when stress, fog, and unclear language collide. In the 1970s, the Ford Pinto became a symbol of what happens when corporate decisions prioritize cost over safety. The Pinto was developed quickly to compete with small imports, but during crash tests, a serious flaw became clear. The gas tank was positioned just behind the rear axle and had no real protection. In rear-end collisions, it was prone to rupture, and in some cases the car could burst into flames. Engineers identified the problem early and proposed fixes, including adding a rubber bladder or reinforcing the fuel tank. These solutions would have cost about $11 per vehicle, but Ford declined to implement them. Internal documents later revealed that the company had done a cost-benefit analysis and determined that paying potential injury and death claims would be cheaper than fixing the design across all units. The flaw went largely unnoticed by the public until a series of accidents, lawsuits, and media coverage exposed the issue. One of the most well-known cases involved a Pinto rear-end collision that killed 3 teenage girls, drawing national attention. Estimates suggest that dozens of deaths were linked to the flaw. In 1978, under public and legal pressure, Ford finally issued a recall. The Pinto case became a turning point in automotive safety and corporate ethics. It raised serious questions about how companies assess risk and how much value is placed on human life in those calculations.